We are going to continue talking about alkynes reaction. This time we're going to study halogenation reactions. Say that we have that, and that is, if we recall nomenclature, 1, 2, 3, and 4, this is 2-butyne. Now, okay. What is the reaction that we are studying then is I'm going to make this darker. It doesn't look like too dark to me. A little bit more contrast, okay. So what we're doing here is then adding a halide, let's see, bromine or chlorine, and say that we do this in carbon tetrachloride. If we have an excess, and we're doing the X could be chlorine or bromine. If we have an excess of the halide, we're going to insert 2 moles. So at the end, you're going to have, say, carbon, carbon, X, 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 and that, assuming that these are metal. Or we can say this is one R group, this is another R group. In that case, it no longer be 2-butyne, right? And so that will be the general case. But this is when we have an excess. And if we have only 1 mole of halide, so that is, we're going to say excess. If we have 1 mole, then we're going to add across the triple bond 1 bromine and 1 bromine. And what is found here is that the major product, if you add 1 mole, would be the following. Say that this is R1 or R2 in this case. R1, you will have the bromine opposite side. And that is in the, say, this major product, and you will also have the other product in which the 2 bromine are added to the same side. So in this regard, it's not as stereospecific as it is the halogenation of alkenes. So I'm going to write that down, so that we remember we're contrasting this reaction with the halogenation of alkenes. When we had an alkene, I'm going to make a line here. If we had an alkene, and we added bromine, say carbon tetrachloride, this will go through bromonium intermediate. So I'm going to write the intermediate down here. So that intermediate bromonium, say that I'm going to let's do this. I'm using this one better now. Much better. That's my bromonium intermediate. Will have a positive charge. And here you will have metal, metal, and here we'll have only 1 metal. So that's your bromonium. And then bromide will attack on the more substituted, and that attack is anti. What that means is that you always form the product that is anti, so that we'll have the 2 bromine opposite sides. And that is important. That's not exclusive in the case of the alkyne. So in the case of the alkyne, then you're going to have major. This reaction is stereospecific. You will get that plus the enantiomer, because of course you can form that bromonium ion instead of being like going towards you, the opposite side, let's say, instead of drawing it in wedges. So again, that's say the most important difference. The reaction is not a stereospecific. You get a mix of this that has the bromine opposite sides, but the other product is also formed. In the case of the halogenation of alkenes, this is stereospecific. We're going to be using this reaction also in the combined with many other reactions that we have seen in alkene and alkynes now in synthesis strategies. So, but we will do that in another video.